Hey everyone. Lesson 2 of rational expressions, we're going to start looking at multiplying and dividing rational expressions. In our first lesson, we dealt with what a rational expression was, and then we took a look at, okay, how can I simplify these? Which usually meant we would factor everything we could factor, and then we could look at which binomials or which factors might divide each other out, okay? With multiplying and dividing, we want to throw those concepts in. Oh, I forgot one thing. In our last lesson, we also talked about non-permissible values, right? You can't have a 0 on the bottom of a fraction. So we have to state the values for our variables that are not allowed in the expression. And those are values that would create a 0 on the bottom of the fraction, okay? Okay, so now we're gonna look at multiplying and dividing. And to do that, really what we need to do is just review how to handle fractions, multiplication and division. And then we'll throw in some polynomials at the same time, okay? It'll be super awesome. Okay, so multiply or divide the following rational numbers. So I've got 3/4 times 1/5. What I want you to remember from way back whenever whoever taught you fractions in the first place, some of you may be like, nobody ever taught me fractions. Somebody did at some point in your life, somebody taught you fractions. We multiply the tops, we multiply the bottoms, okay? So in this first one, I've got 3 times 1 is 3, 4 times 5 is 20. My answer is 3/20. That's simple. Okay, now in the next one, you may look at that and say, okay, well, I'd have to go 6 times 14 and 7 times 9, and that is absolutely true. But what I want to do is I want to set it up in a different, it'll look a little different, but it's going to make total sense when you see what we're actually going to work with today, okay? What I'm going to do is I'm going to think about factors. I'm going to take my 6, and I'm going to say, hey, let's call that 2 times 3. And I'm going to take my 14 and I'm going to say, hey, let's call that 2 times 7. And I'm going to take my 9 and I'm going to say, hey, let's call that 3 by 3. That's a lot of hays. Okay, so I've got 2 by 3, I've got 2 by 7, and then I've got 3 by 3. Okay. Now, why would I do that? Well, because what I want, here's the concept I really want you to get comfy with. When I'm multiplying, now that I have all of these factors here, multiplying, you just multiply the tops and multiply the bottoms, right? Well, what that means is this whole line can actually be 1, okay? I don't really need that multiplication statement anymore because it's just gonna be 3 times 2 times 2 times 7 on the top, and on the bottom, it's gonna be 7 times 3 times 3. Now, some of you are looking at that and say, okay, but why did you break it up? Because take a look at this. I can say those 3's divide out. I can say those 7's divide out, and I don't even have to do the multiplication of those anymore. What I can do is 2 times 2 is 4, and then I have a 3 on the bottom. So I know my answer would be 4/3. Okay? Awesome. Okay, so that's all we're really doing today. It's just gonna look a little messier, but we can deal with mess. Okay, let's talk division now. Remember, or maybe you don't remember, but I'm going to tell you, when we divide fractions, what we do is we can change the division to multiplication, and then we flip the second fraction. So dividing by 1/3 is the same as multiplying by 3/1, okay? So we change it to multiplication, and then we flip the second fraction. So I've got 3/4 times 3/1, and that would give me 9/4. Over here, I'd have 5/4 times 1/2, right? 2 flipped. 2 is 2/1. So if I flip that, that'd be 1/2. And then that would give me 5/8. Okay? All right. So steps for multiplying and dividing. Your first steps, no matter what the rational expression is, your first steps are always the same. You want to factor everything, and then you want to state all the NPVs. Okay? Then you want to simplify by dividing out binomials that are the same or factors that are the same on the top and on the bottom. As long as it's multiplication, anything on top can go with anything on the bottom, right? They don't have to necessarily be on the same fraction because multiplication, all that top is going to come together and all that bottom is going to come together anyway. Okay. Okay, so simplify the following and state all NPVs. So we've got 23 m squared n over 15 times 5mn over 8n squared. Well, let's talk about NPVs first. I've got an n squared on the bottom, so that means n can't be 0. Okay, now let's talk reducing. I see a 5 over 15 here. I could reduce that. Both of those are divisible by 5, right? So that could be a 1 and that could be a 3 if I divide both of those by 5. I'm just reducing essentially 5 over 15. On the top, I've got 23 times 1, so that'll be 23. M squared times m, that's like m to the 1, so that'll be m to the 3. N times n is n squared. On the bottom, I've got 3 times 8, n squared. Okay. Now, my n squares will divide out, and 3 times 8 is 24. So my final answer will be 24 m cubed, sorry, 23 m cubed over 24. 23 m cubed over 24. Okay. All right. We got messy really quick. Now remember, just like I did in the last lesson, I'm not going to go through the steps of factoring as much anymore. There'll be a couple of times that I'll do it in maybe 2 steps. But what you're going to want to do is pause, do the factoring however you like to factor, and then make sure that your answer matches my answer. Okay. Now for this one, I am going to do this in 2 steps. I'm going to take out a 2x from this top left corner here. And that would leave me with 2x bracket x squared plus 5x plus 6. Down below here, I can take out a 2x, and that would leave me with x plus 7. X plus 7 here, I can't do anything with. X squared minus 9 is the difference of squares. Those things that kids hate to find, or not hate to find, but never find. X squared minus 9, x plus 3, x minus 3. So here's where I am. Okay, now, the x squared plus 5x plus 6 can be further factored. Looking for 2 numbers that multiply together to give you 6, add together to give you 5, that'd be 2 and 3. Okay, so now I have everything in fully factored form. Once I have everything in fully factored form, I'm ready to have a conversation around my NPVs. I know that x can't be 0, x can't be -7, x can't be -3, and x can't be +3. Okay, so I've got 0, -7, -3, and +3. Okay, now I want to say or think, what can I divide out? Well, 2x divided by 2x is 1. X plus 7 divided by x plus 7 is 1, right? As long as one's on the top and one's on the bottom and they say the same thing, I can divide out. X plus 3 over x plus 3 can divide out. So I'm left with x plus 2 over x minus 3. Okay, x plus 2 over x minus 3. Now, I don't know if you paid attention to the little picture that I had at the beginning of this, but don't look at this and say, oh, x divided by x is gone. No, it's not. Okay, the picture I had at the beginning is every time you do that, a kitten dies. This x is not standalone. This x is a part of an x plus 2. So you cannot divide those x's out. You can divide an x plus 2 with an x plus 2, or you can divide an x minus 3 with an x minus 3. This x is not a standalone. Whereas, I want you to really pay attention to this because this causes confusion, and I don't want it to. I want you guys to feel really, really good about it. That's different from these x's here. I did get rid of those x's because those x's are standalones. They are being multiplied by everything else. This x down here is not being multiplied by everything. It's being added with 2. And down here, I've got x minus 3. As soon as you have an addition or subtraction sign, those 2 terms glue together, okay? And so you have to be very, very careful that you understand when you can divide out and when you can't divide out, okay? Awesome. Okay, so now we have a division one. I've got x plus 7 over x squared minus 9 divided by x squared plus 9x plus 14, all over 3x squared minus 9. So a couple things we want to do. first we want to factor everything. So I see down here, I've got x plus 3, x minus 3, because that's the difference of squares. Up here, I'm looking for two numbers that multiply together to give me 14, add together to give me 9. That's going to be x plus 7 and x plus 2. And then here I've got, I'm going to take out a 3x, and that'll leave me with x minus 3. Now, I've done all that factoring. The other thing I'm going to do is I'm going to rewrite this as a multiplication statement. And I'm going to flip the second fraction, okay? Because I'm going to multiply by the reciprocal. So my next item that I'm going to show you, I've got everything factored, but I also have changed it to multiplication and I flipped it, okay? And so we're looking at this. Okay, so now I want to do NPVs, but there's a little conversation I need to have about NPVs. I told you earlier, we only care about the bottom. That's true. But we only care about anything that is the bottom at any point in time, okay? What I want you to think about is I just flipped that second fraction. If I flipped that second fraction, both parts of that fraction are the bottom at some point. So when I'm looking at NPVs, I'm actually looking at everything I've just highlighted here, okay? The only thing I don't care about was this first guy up on the top because he never got flipped. Okay, so x can't be -3, x can't be 3, x can't be -7, x can't be -2, x can't be 0, and I've already said x can't be 3. Okay, so my NPVs are -7, -3, -2, 0, and 3. Okay, now I have this written as a multiplication statement. So I can take a look at, hey, what can I divide out? I know my x plus 3, oh, no, x plus 3 cannot divide out. I'm going to take that away. My x minus 3s can divide out. My x plus 7s can divide out. And that'll be it. So I'll have 3x on the top. And then on the bottom, I'll have x plus 3 times x plus 2. Okay, 3x on the top. And on the bottom, x plus 3 times x plus 2. Cool. Well, this one looks a little scary. We can do this. Don't worry. Okay. Here's what I need you to see. This guy here just means division. So I think the first thing we should do is we should write this as a left to right statement instead of having these complex fractions. So I want you to look at this and say, okay, I'm going to take that guy, I'm going to divide by that guy, and I'm going to times by that guy, okay? So that's what I've done right here. It's 3x plus 12 over 3x squared minus 5x minus 12. Then I'm dividing by 12 over 3x plus 4. And then I'm multiplying by 2x minus 6 over x plus 4. All right, so now I'm ready to factor. This guy here, I can take out the 3, and I'd be left with x plus 4. This guy down here, I'd be looking for two numbers that multiply together to give you negative 36 and add together to give you negative 5. Okay, so those numbers would be negative 9 and positive 4. So I know I need a 3x and an x. To get my negative 9, that's going to have to be there. So that'll be a negative 3 to get my negative 9. And then my positive 4 will go right there. Okay, so that guy factors into 3x plus 4 times x minus 3. Here, there's nothing to factor. Here, I can take out a 2 and I'd be left with x minus 3. Okay, so that's all my factors. I'm going to rewrite this in factored form, but also when I write it in factored form, I'm going to deal with this guy as well. I'm going to change him to multiplication, and then I'll flip that second fraction. Okay, so 12 will go to the bottom and 3x plus 4 will go to the top. So that's what I've done on the next animation that you're going to see. Okay, perfect. Okay, so now I got to talk about NPVs. A reminder, for NPVs, it's all of the bottom and anything that was once the bottom. So my NPVs are actually coming from everything I've highlighted here. So here is going to be 3x plus 4 can't be 0. That ends up being x can't be negative 4 over 3. Here, x can't be 3. 12 is inconsequential. There's no variable with it. This is negative 4 over 3 again. I've already taken care of that. And then this would be negative 4. Okay, so overall I have 3 NPVs, negative 4 over 3, 3, and negative 4. Okay, so x can't equal negative 4 over 3, and 3. Now I'm ready to divide out common binomials that are on the top and on the bottom. So 3x plus 4 would divide out. X minus 3 would divide out. Whoops, did you see what I did there? That was silly. Let's just take that away and say x minus 3 is divide out. Okay, then my x plus 4 is divide out. Okay, so what am I left with? Well, I have a 3 times a 2 on the top, so that's going to be a 6. And then I've got a 12 on the bottom. So overall, I'm left with 6 over 12. 6 over 12 reduces to 1/2. Okay, 1/2. See, so it wasn't as scary as it looked, right? All right. So friends, that's where we're going to end today. I've given you your homework here. The next thing to talk about is adding and subtracting. That one's a little harder. We're going to divide that into 2 different lessons. Okay, so we'll get part 1 and part 2. As always, make sure you're going through this stuff. Make sure you are clear in your communication. You're checking your answers. You're devoting lots of time at home to studying. And you're connecting with me. I absolutely love your questions, so please keep them coming, okay? You can do this. We'll see you next for adding and subtracting. Take care.